Welcome to Dig Into Geology with Miss Jennifer and Mr. Jeff at Indian Trails Public Library. Today we're going to talk about 3 types of rocks. We're going to learn all about earth science and join us at the very end for a special craft video. We hope you enjoy today's program. We want to remind you that we have 2 reading programs and we think you'll really like them. We have, if you are in kindergarten through 2nd grade, you can join us for tag-along reading and earn prizes just for reading. If you are in grades 3 through 5, you can collect rocks and gemstones just for reading. And we have online registration at the Indian Trails Library website. We'll also be sharing our slides, and you can click the links within the slides to access the online registration. So today in our program, we're going to learn 4 things. We're going to learn about the 3 types of rocks and how they are formed. We are going to learn what fossils and geodes are and where you can find them. We will also learn what an earthquake, volcano, and tsunami are and how they are formed. And at the end, we're going to show you about some ways that you can get involved in earth science and ecology and learn more. So there are 3 basic types of rocks, and we're going to show you examples of each of these rocks, and we'll give you some characteristics of each of the rocks. The first one we'll talk about are igneous rocks, and then we'll have sedimentary rocks. And finally, we'll talk about metamorphic rocks. And you may have seen these and not realized what type of rock they are. So we're going to start with igneous rocks, and Mr. Jeff is going to talk to you about what they are and then show you some examples of igneous rocks.
Hello everyone. All right, so igneous rocks are formed by the cooling and solidification of molten earth material called magma. And magma originates deep within the earth near active plate boundaries or hotspots. There's 2 types of igneous rocks that are important to remember, and those are intrusive and extrusive. Intrusive igneous rocks are those that form below the Earth's surface. Extrusive igneous rocks are those that form at or above the Earth's surface. For intrusive rocks, those are slow cooling and they allow minerals to grow and more grains, so that they tend to grow very large in size. These usually have a coarse or rough feeling or texture, and it takes millions of years for an intrusive rock to solidify. For extrusive rocks, this is when lava erupts and it oozes around the Earth's surface and it cools as the lava cools down. These rocks form quickly, and you can often see the gas bubbles that are trapped inside. When magma rises above the Earth's surface, it's called lava. Did you know that the U.S. National Monument called Devil's Tower is located in Wyoming? That's an igneous rock. You can click on the slide to learn more. These 2 types of igneous rocks are both extrusive. The first one is called scoria, and you can see that it's usually dark in color and it's highly vesicular. So vesicular is those cavities that are formed. You can kind of see there's like little wrinkles and bubbles in there. That's when there were gases inside the lava that were cooling. Sometimes the lava flows near the surface, and scoria is usually referred to as cinder. This could be used for high temperature insulation, and it's often used in landscaping as well. Scoria is denser and heavier than pumice, and scoria usually sinks in water. The one to the right is pumice. This is usually typically lighter in color. It's also highly vesicular, but this has a rougher texture. It's created by highly pressurized rock being ejected during the eruption. Pumice usually floats on water because it's very lightweight and it's not as dense as scoria. It kind of has a foamy appearance. The word pumice is derived from the Latin pumex, which means foamy. Pumice is also abrasive in nature, and it's used in many personal care products, such as the removal of unwanted skin or hair. Next up, we have gabbro and tuff. Gabbro is an intrusive igneous rock. It's coarse-grained, and it's formed from slow cooling magma that was rich with magnesium and iron. It's named after an area in Tuscany, Italy, where it was first found. Much of the Earth's oceanic crust is made of gabbro, and it can often be found in ophiolioites, which is sections of the crust that's been uplifted above sea level. Tuff, on the right, is an extrusive igneous rock made from volcanic ash, which is being ejected out of like a volcanic vent. Tuff is usually soft, and it's primarily used in construction in ancient times, particularly with the Romans. There's a lot of different kinds of tuff. On our next side, we have rhyolite and diorite. Rhyolite is an extrusive igneous rock, and these are usually pink or gray in color. It has a felsic composition, which means it's silica rich. It may have a texture from glassy to aphanitic or porphyritic. The mineral assemblage is usually quartz, sandinine, and plagioclase. Diorite is an intrusive igneous rock, and these are usually gray to dark gray in color. The crystals are usually visible, and you can kind of see it sparkling if you hold it up to the light. This rock is hard, so it's difficult to carve or work with, but it's durable and it can be fine polished and withhold over a long period of time. Up next, we have granite and basalt. Granite is an intrusive igneous rock. There can be white, pink, or gray in color, lots of different variations. These are usually very large, hard in nature, and they're coarse-grained and tough. Granite's commonly used in construction. It's more common in the continental crust rather than the oceanic crust. Basalt is an extrusive igneous rock. Basalt's very hard. It's also usually gray or dark in color, but it weathers easily over time. This is the most common volcanic rock, and it's estimated that 90% of all volcanic rock on Earth's surface is basalt. Next, we have obsidian and pegmatite. Obsidian is really easy to spot because it's smooth and glassy. This is an extrusive igneous rock. It's usually black or very, very dark blackish green. It has minimal crystal growth. It's very hard, but it's also brittle. It used to be used in experimental, like surgical or scalpel uses, but this has not been approved for safe use, and so it's no longer used for surgery. It's often used for a lot of like different decoration and jewelry now. Pegmatite is an intrusive igneous rock, which is formed underground, and it's smaller than many intrusive formed rocks. It has a large crystal component. They're all bound and intertwined crystals, and the most popular ones in here are quartz, feldspar, and mica. Pegmatites are important because they often contain rare earth minerals and gemstones such as aquamarine, topaz, fluorite, apatite, corundum, often along with tin and other materials. That's it for our igneous rock collection.
And now we'll talk about sedimentary rocks. And sedimentary rocks are formed by the accumulation or deposition That's a hard deposition.
Oh yeah.
Deposition of smaller fragments of broken off pre-existing rocks, minerals, or organic particles. Smaller particles are cemented together. So there are three main types of sedimentary rocks. There's clastic, which are little pieces of broken rock that are compacted and cemented together. There are chemical sedimentary rocks, and those are formed when dissolved materials, those are formed from dissolved materials when water evaporates. And then there are organic sedimentary rocks, and those are the accumulation and cementation of organic pieces, such as calcium bits left over by animals, such as shells, bones, and teeth. And I found one of the most fascinating sedimentary rock formations in the world is right here in the US, in Utah, and it's called the Wave. And if you are to go visit Utah, you can go and sign up for a tour to go see the Wave. And when you click that link, you can read more and see pictures. It's really, really cool. So we have several types of sedimentary rocks to show you. First, we have sandstone. And sandstone is most commonly tan, brown, yellow, red, gray, pink, white, and black. It's a popular building material. It's one of the most common sedimentary rocks. And much of the sand-sized grains that you see are organic material along with cementing material, and that binds the sand grains together. Now on the right-hand side, you see limestone, and limestone is comprised primarily of calcium carbonate in the form of the mineral calcite, and it's most commonly formed in clear, warm, and shallow marine waters. And Earth has many limestone forming environments. Most of them are found in shallow water areas. And when very small marine organism animals die, their shell and skeletal debris accumulate as a sediment that might be lithified into limestone. So as we described the types of sedimentary rocks, limestone is most likely an organic sedimentary rock. Next, we have rock gypsum and travertine. And gypsum is an evaporite mineral. And so that means it's formed from the evaporation of liquid. It's used in the construction of drywall and plaster. So the walls in your home are probably made from gypsum. Travertine is a form of limestone, and what makes this special is it's deposited by mineral springs, especially hot springs that can be found in limestone caves. And I discovered that the lobby walls of the Willis Tower or the Sears Tower in downtown Chicago are made of travertine. I thought that was a really neat fact. Next, we have coal. And most people have heard of coal. It is an organic sedimentary rock, and it forms from the accumulation and preservation of plant materials, usually in a swamp environment. And it's one of the most important fossil fuels. You may have heard a lot about fossil fuels in the news or in school. Electricity production is the primary use of coal in the United States. But the thing with coal is it's not a clean burning fuel. And so that's why you hear a lot about wind energy and alternative forms of energy, because coal can pollute the air. Rock salt is also called halite, and it's got that really neat, shiny, clear look to it. It forms from the evaporation of seawater or salty lake water. And rock salt, in its most natural form, as you see here, might sound like something that you can put on your food, but it's different from the table salt that we use for food. You may have heard of rock salt to melt snow, and that's because it's a different type of composition than table salt. So you don't want to eat rock salt. And next up, we have metamorphic rocks. And Mr. Jeff will talk to you about metamorphic rocks.
Metamorphic rocks are a type of igneous or sedimentary rock that has been transformed or metamorphosized through intense heat or pressure. Metamorphic rocks make up a large portion of the Earth's crust, about 12% or so. Through identifying the way the rock's layers are formed, we can identify changes in temperatures and pressures of the Earth's crust. The layering within metamorphic rocks is called foliation, which you can see identified by bands of colors or textures. These are formed through the rock's metamorphosis or transformation over time. The texture of a metamorphic rock helps identify what type of rock it is, how big the crystals are that make up the rock, and how thick the foliation is. The rarest type of metamorphic rock is considered to be lapis lazuli, which is blue in color and often used to make jewelry. You can click on the link in the slide to learn more. Foliated metamorphic rocks such as gneiss, phyllite, schist, and slate have a layered or banded appearance, and that's produced by exposure to heat and directed pressure. And whereas non-foliated metamorphic rocks such as hornfels, marble, quartzite, and novaculite do not have a layered or banded appearance. Pictures and brief descriptions of some common types of metamorphic rocks will be shown. So first up, we have chlorite schist and graphite schist. Schist is a foliated metamorphic rock made up of plate-shaped mineral grains that are large enough to see with an unaided eye. It usually forms on a continental side of a convergent plate boundary. Each of these rocks are similar in how they were formed, but combined with two different minerals. One has chlorite and one has graphite. Chlorite is the main mineral in the left photo, where graphite is the main mineral in the right photo. Many valuable gems such as rubies, emeralds, and sapphires form in schist rocks. There's also mica schist. Mica schist is a form of a schist rock where the main mineral comprised in the rock is mica. Micas, feldspars, and quartz usually account for most of the minerals present in schist. To the right, we have serpentinite. Serpentinite is a dark, typically greenish metamorphic rock consisting largely of serpentine or related minerals, and it's formed when igneous rocks are altered by water. They are often green in color and look like snake skin, which is how they got their name. Serpentinite is often used in jewelry or used to make sculptures. Up next, we have two different kinds of marble. On the left, we have a regular marble, and to the right, we have a dolomitic marble. Marble forms when limestone is subjected to the heat and pressure of metamorphism. Remember, limestone is a sedimentary rock. So marble occurs in large deposits that can be hundreds of feet thick and cover large areas of land. Marble is usually light in color and easy to carve. This is why it has so many uses and used in highways, railroad beds, building foundations, and other types of construction. Sawed up pieces of marble are found in monuments, buildings, sculptures, paving, and other projects. Dolomite marble is found in sedimentary rocks, and it's often white, gray, or pink in color, as you can see in the picture. Dolomite, which is similar to limestone, metamorphosized from heat and pressure. Up next, we have amphibiolite and gneiss. Amphibiolite is very coarse-grained, green, brown, or black in color. They are part of a rock-forming mineral group called hornblende. Garnet gemstones can be found in these rocks, which can be very exciting. Gneiss is a foliated metamorphic rock and has many gradations. Its formation usually begins as shale. The most common type of gneiss is used in countertops of homes, although it's called granite, which is not, this is not accurate. A lot of the times it's actually gneiss. You may have a kitchen counter made of gneiss. On the left, we have epidocite. Epidocite is a highly altered combination of epidote and quartz, and it's caused by the slow hydrothermal alteration with heat and pressure. Epidocite can be translucent when marbled. It's very hard in nature, and it can be found in schists and marbles. It can also be used for simpler types of jewelry, like little brooch stones. On the left, we have quartzite. Quartzite is a type of quartz sandstone that has been transformed from heating and pressure as well, and it's related to tectonic compression when you have those plates pressing together. It's grainy, glassy, and it usually has a sandpaper surface. It comes in various shades of pink and red due to varying amounts of iron oxide. Other colors such as yellow, green, blue, orange, and other colors present will be due to other minerals within it. Quartzite is a decorative stone and may be used to cover walls, roofing tiles, or it could be used as flooring and on stair steps. During the Paleolithic period, quartzite was used along with flint and quartz for making stone tools. That is our metamorphic rock collection.
Rocks are everywhere. They are large and small, heavy or light, porous or dense. But rocks in some shape or form can be found all over the planet. Different types of rocks are formed in different ways. There are three main types of rock: igneous, sedimentary, and metamorphic. Igneous is a word that means fiery. Igneous rock is formed when magma or lava cools. Sometimes magma cools slowly underneath the Earth's surface. This forms intrusive igneous rock, like granite. Other times, lava cools when it comes to the surface in a volcanic eruption. This forms extrusive igneous rock. Some examples of extrusive igneous rock are tuff, obsidian, and pumice. Igneous rocks make up about 95% of the Earth's crust. The next type of rock is sedimentary rock. Sediment is small particles of sand, mud, and organic material that settle to the bottom of water or land areas, often lakes or oceans. Sedimentary rocks are formed when sediment accumulates over time in deposits that form layers. These layers become squeezed and compressed over time until they consolidate into a rock. Sedimentary rocks are the types of rocks in which fossils may be found. since the process of forming sedimentary rocks can preserve plant and animal remains that are deposited into the sediment layers. Some examples of sedimentary rock are limestone, shale, and sandstone. The third type of rock is metamorphic rock. The word metamorph means to change form, and metamorphic rock is rock that has been changed by extreme heat and pressure. Sedimentary rock, igneous rock, or even other metamorphic rocks can be changed by heat and pressure into new kinds of rock. Metamorphic rocks can be formed by being deep under the earth where pressure and temperatures are high, or when rock near the surface is heated up by the movement of tectonic plates or magma. Different types of rocks become different types of metamorphic rock when exposed to heat and pressure. For example, shale becomes slate. Sandstone becomes quartzite. And limestone becomes marble. Rocks are slowly but constantly changing in something known as the rock cycle. The rock cycle begins with magma, or hot melted rock, deep beneath the Earth's surface. This magma becomes crystallized, becoming igneous rock. These rocks begin to erode or break down into small pieces because of wind, water, or other forces. The small fragments of rock are carried away as sediment when water passes over them and are deposited in layers, which eventually become sedimentary rocks. Then, some sedimentary rocks are pushed below the surface due to tectonic activity, where they are exposed to heat and pressure, transforming them into metamorphic rocks. If the rocks are buried even deeper, they may melt and form magma, starting the cycle all over again. Of course, sedimentary and metamorphic rocks can be eroded into sediment, and igneous rock can become metamorphic rock or lava. But one way or another, rocks all over the world keep changing from one form to the next.
Well, that was a really great video, and I hope you found that useful and helpful in learning about what we're talking about today. So next we want to tell you briefly about what a geode is, and you can see some really cool pictures of a geode in our slides there. And a geode is a formation of mineral matter or crystals within sedimentary and igneous rocks. And minerals from groundwater or hydrothermal areas fill in bubbles or hollow spaces inside. And usually you can't tell from the outer shell of a rock if it's a geode. You have to break it open, which is why you see them kind of like an egg shape sliced open. And the word geode comes from the Greek word geoids, which means earth-like. And we have a link there at the bottom. You can click that to see some other really cool pictures. Now, another way to find out if a rock is a geode is if it feels lighter than the other surrounding rocks, because they have the hollow space inside. So you can shake it and test it to see if you hear anything kind of rattling around inside, and those are the crystals that have formed inside the rock. A fossil is any preserved remains, impression, or trace of a once living thing. And you can see two pictures there of fossils. Bones, wood, plants, hair, even DNA can become fossilized. And fossils can form in many ways, including permineralization, which is what happens when an organism is buried, and paleontology, which you may know about from learning about dinosaurs, is the study of life on Earth by looking at fossils. And the word fossil comes from the Latin word fossilis, meaning obtained by digging. And there are two very famous and impressive fossils that you can read about. One you may have seen at a museum in downtown Chicago, and that is Sue, the Tyrannosaurus Rex. And that was the most complete and preserved dinosaur that has been found. And it was found in August of the year 1990. Another famous fossil of all time is called Lucy. And it's a 3.2 million year old human species. It's known to be one of the earliest humans. And it is a complete skeleton of an erect, which means standing, walking human being ancestor. And it was found in the Ethiopian region over 40 years ago.
So in geology, a lot of the formation of rocks happens during earthquakes or when tectonic plates compress or move against each other. So how does an earthquake happen? The surface of the earth shakes when sudden energy is released inside the earth, and this causes seismic waves and movement along fault planes. So there's three different types of fault planes, and you can see this in the picture over the right-hand side. There's a strike slip, which is A, it's when they're moving against each other. There's the normal slip, there's the normal fault, which is when one is going down against the grain. And then there's also a reverse fault, which is when you can see the one moving up against the other one. Usually caused during the rupture of geological faults, but earthquakes also happen during volcanic activity, landslide, or even man-made disturbances. Some of the most famous earthquakes include the 1906 San Francisco, California earthquake. In 2011, there was a really bad one that hit Tohoku, Japan, which caused a lot of other tsunamis and environmental disasters. In 1960, there was the Valdivia Great Chilean earthquake, and this was the largest earthquake ever recorded, which was a 9.4 to 9.6 on the moment magnitude scale. And this one resulted in tsunamis that affected southern Chile, Hawaii, Japan, the Philippines, eastern New Zealand, Southeast Australia, and the Aleutian Islands. Why does a volcano erupt? Volcanic eruptions happen when there is a rupture in the crust of a planet, allowing lava, ash, and gases to escape from interior chambers. They frequently occur where tectonic plates meet, where the crust of the planet is thinner and are often found underwater. A volcanic mountain can form from the accumulation of dried lava and ash over time. Some of the most famous volcanoes in recent time include Mount St. Helens, which erupted in 1980. And many of you might have heard of Mount Vesuvius, which in 79 destroyed the city of Pompeii as well as other Roman cities. Tsunamis. What causes a tsunami? When a large displacement of water occurs from an earthquake or other seismic event that causes a large wave, tsunamis can cause the sea level to rise inches or even 100 feet. But typically, most of the waves stay below or at about 10 feet. An approaching tsunami can create a large roaring sound like an approaching plane or even a train. It gets very loud as it's coming closer. Some of the most famous tsunamis in recent recorded history include the tsunami in Sumatra in Indonesia. This was in December of 2004, when the Indian Ocean earthquake and tsunami happened. And this was caused by an undersea megathrust earthquake, which was caused by a rupture along fault line between the Burma Plate and the Indian Plate. And this created a series of waves up to 100 feet high. Another one happened on March 11th, 2011 in the North Pacific coast of Japan. And this is what caused the waves of up to 133 feet off the coast of Tohoku. This was also what caused the nuclear accidents at that power plant in Japan. In 1965, there was a great Alaskan earthquake and tsunami. And in 1755, there was a famous earthquake and tsunami in Lisbon.
So that's the end of our descriptions of rocks and earth science type events. We have a slide here if you would like to learn more about these topics. There's so much information online that you can find. Each of these links will take you to a new website, and we hope you check them out. And then on our next slide here, we have a video of the Earth Book by Todd Parr. And it's a fun reading that Todd Parr does, and you can play that at your leisure. Now, if you want to learn more at the library, we have lots of books, DVDs, and ebooks that you can find, and you can check them out now at the library when we open up and do the drive-up window. And we hope you do that. So that's the end of our presentation. Stay tuned. We have a craft video for you where you can use rocks and gemstones to create a piece of jewelry or a keychain, and we hope you enjoy it. Thank you for joining us today.
Have a good one.
Hey everyone, it's Mr. Jeff. So we're going to make something that deals with the inner core, the outer core, the mantle, and the crust of the earth. Join me in the kitchen. All right, so here we have our supplies. We have the Rice Krispies, which I measured out into 2 cups over here. I have Hershey's chocolate syrup. It said to use hard shell, but this is all I have, and we're going to try and freeze it and see how that works. This is for the outer crust. Recipe says for 13 marshmallows. We need about 2 tablespoons of butter. Got a plate to do some working on. Get your hands messy. One recipe called for red hots. I'm going to use an M&M. That's going to be the inner core of the earth. We have a knife, spoon. I'm going to have another bowl so that I can put this in the freezer. So what are we going to do to start? We're going to have our inner core and we're going to put it inside the outer earth's core. So all the kids, you guys could do this. This is something that's going to take a little bit of collaboration and working together. Some of the other steps you're going to need an adult, okay? So I'm just ripping open the marshmallow here, and I'm going to stick the core inside like that. I'm going to squish it together. I'm going to take the remaining marshmallows, put about 2 tablespoons of butter in. So this is the part where you get an adult, and then now it's time to microwave. This is going to turn into your mantle. You could also use a spatula to stir up the mantle. All right, so here is the melted bit of marshmallows and butter. This is going to be part of your mantle. Now you're going to pour in the rest of the cereal. And we're going to stir this together. We're going to want to let this sit about a minute after we're done stirring because it's still really hot and you don't want to burn your fingers. A spatula might be a little bit better in this situation. Mix all those minerals and rocks together. Once you let it sit for about a minute to cool off a little, wet your hands a little bit so that you can mix it all together and it won't be too sticky. Otherwise it'll all stick to your hand. You'll have mantle hands. So we're going to take this over to the plate. We're going to take the inner core and the outer core and we're going to mix it. We're going to build the mantle around. Looks like Earth, right? No? That's because it's missing its crust. So here we have that red M&M inside, and then we have the marshmallow, which is the inner and outer core, and then this, the Rice Krispies, the marshmallows, and the butter, makes up the Earth's mantle. And now, for the last part, we're going to add the crust. Is going to be the chocolate syrup. If you have, let's pour all this all over. And I'm going to put this in the freezer. All right, let's cut this here. Oh yeah, look at that. You can see the inner core, which is the red M&M, surrounded by the outer core, which is that first marshmallow. So check that out. Edible Earths, you guys. I hope you guys make something tasty at home. We'd love to hear about it. Hope everybody's doing well. Enjoy your tasty treat while you learn about geology. Have a great day. Bye.
Hi everyone, this is Miss Jennifer from the Indian Trails Public Library, and I'm here to show you how to make a very simple beaded bracelet. I am using materials that I already have at home. You may have similar materials. You can also purchase these materials at your local craft store or online at probably a place like Amazon. This is also to go along with our Dig Into Geology program. Now, what we're going to do first is gather our supplies. And what I have here today is a pair of scissors, a piece of tape, I also have some hemp twine, and this is a very thin hemp twine. You can also use a nice white kite string or a thicker piece of thread. I would avoid using a thin type of sewing thread because your bracelet might break because of the thinness of the rope. And I also have some charms. I have 4 charms here. You don't have to use charms. You can use 1 charm. You can use as many charms as you like. Again, these are just things that I had at home, and so I'm going to add them to my bracelet. The most important part of my craft are beads, and I have a whole container here of different beads, which are made of real rocks and gemstones from all across the world, and they're all different sizes, all different shapes, all different colors. And I've chosen 16 different beads to make my bracelet. And another important part of our bead is that they have a hole in the middle of the bead so that we can thread our twine through our bead. So whatever you choose to make your bracelet, You just have to make sure that it has a hole through it, like that. And so I've gathered my supplies, and I'm ready to start. The first step of our craft is to measure and cut our twine. And so what I'm going to do is I'm going to wrap it around my wrist to gauge how big of a bracelet I want to make. And then I'm going to leave about 2 to 3 inches at the very end to allow for the bracelet to be attached together so the bracelet doesn't fall off my wrist. And then, so when I open it up, my twine looks like that. And then I'm going to double it by going like that with my twine. And I'm going to put my finger at the very end and open it up. And I'm going to cut it right there. And the reason I'm doing this, and now I'm going to put my twine aside. The reason that I do this is because we're going to be using 2 pieces of twine, this same size, and we're going to be making knots. And the knots will shorten the bracelet. And so I want to make sure I have enough twine to wrap around my wrist. There's nothing worse than getting all the way to the end of your craft and it won't fit your wrist. So we can always cut off the extra, but we can't really add to it. So that's why it's important to have a long piece of twine. Now, as I said, we're going to be using 2 pieces of twine. So I'm going to cut another piece. And there we go. I have my 2 pieces of twine, and now what I'm going to do is gather them at the top, and I'm going to knot them together. And what I'm going to do is just a very simple loop, and I'm going to wrap it around my finger, push through the end, and pull. So your knot is like that. And then what I'm going to do is I'm going to take this end, and I'm going to take my piece of tape that I ripped off earlier, and I'm going to tape it down to my work surface, which is my desk right here. And the reason that we're doing this, and so I'm just going to go like this. So you want your work surface is going to start right below the knot. And I'm going to tape that down to my desk. And the reason that you're doing this is because as we bead and knot and pull our string, it's going to move around a lot. And so we don't want to lose our place, and we don't want a very loose bracelet. We want it to be, we want the beads to be fairly tight together and our knots to be fairly even and tight. And so the tape down on our work surface helps keep our twine in place. So now we've got our 2 pieces of twine taped to our desk, and we have a right piece and a left piece. Our next step is very simple. We're going to take one of our beads. I'm taking this one right here, which almost resembles a tiger's eye. And I'm going to thread it through. Just like that. I'm going to pull it all the way down. And then I'm going to take my 2 pieces of twine, and I'm going to make a very simple knot just by pulling down our 2 pieces of thread. It's as simple as that. I'm going to then take another bead, and I'm going to use the left piece of twine. And so I'm going to take my next bead and I'm going to thread it through my left piece of twine. I'm going to slide it all the way down. And now I'm going to take my 2 pieces of twine. I'm going to make a simple knot. And now I have 2 beads. So I'm going to continue beading my bracelet and adding my charms until I thread my entire bracelet. What I'd like to show you now is how I'm attaching the charms. And so what I've done is taken one of my strings, and if you notice, the charms have a little ring, and I'm just threading them through as if I would one of the beads. And I'm going to make my knot just as I would with one of the beads. And there you have your charm attached. What's important when you're putting on your charm is that you want to make sure whenever you put on your charm that you're always attaching it either on the right side or the left side. And this way the charm will lay in the same direction. And so all of my charms are going to be attached on the left string, so that when I hold up my bracelet, they're all dangling in a similar direction. And so finally, we have our bracelet with all of our charms and all of our beads. To finish your bracelet, you can simply tie the ends together and slip it on your wrist. What I've chosen to do is I'm going to add a button loop. And I found an old button. And what's important about this button is that it has a little hole there. And so I took the extra pieces of thread and tied them around the little buttonhole. Now what I'm going to do next is take the longer ends. I'm going to wrap it around the button so that I know how big approximately to make the buttonhole. And then I'm going to tie my 2 ends. I'm going to keep them a little loose, so you don't want to go all the way down to the very bottom of the button, because you want to be able to have room, so probably just about to the top or so of the button. Just like that. Because you want to be able to have room to maneuver your button. And then I'm just going to simply tie a knot. And then I'm going to snip off all these little extra threads. Snip those just like that. And I'm going to wear my bracelet. And there you have a bracelet that you made. Now what's neat about this? Comes right off. You can also use this as a keychain. You can use different colors. So you can use all blue, you can use all green, you can use all pink, purple, whatever colors you like. You can use different beads. There's plastic beads you can get. And you can customize this however you like. You can then, if you make it into a keychain, you can attach a little silver hoop, like a keychain hoop, and attach your keys onto there. So that's it for our craft. I hope you had fun, and I hope you enjoyed learning how to make your very own beaded bracelet or keychain using rocks, gemstones, objects you have at home, and I hope you learned something today too. Thanks.